All right, welcome back. So the purpose of this video is we're gonna delve a little bit into residuals and kind of what they really mean and how to interpret them in regard to this particular example with our baseball data. And so remember, each case or observation in the data set is going to have its own fitted value that is the response that the model is predicting for it. And therefore, it's going to have its own residual as well, which is just the difference between the observed number of runs scored and the number of runs scored predicted using our simple linear regression model. And so let's go ahead and see what these residuals look like graphically. And so we've got the Texas Rangers, which is a baseball team who had 855 runs in this particular season, and their batting average was 28.3%. And so it's easy enough to figure out what the Texas Rangers fitted value is. All we're going to do is take our fitted regression equation from the previous page and just plug in 28.3 for x, which is our batting average. And so if you figure that out, that turns out to be 840.7 runs. The residual calculation is also pretty easy. And so the residual for the Texas Rangers is their observed number of runs minus what we just predicted based on our model. And so since they actually had 855 runs, then their residual in this case is 14.3 runs. We can repeat the same exact thing for a different team, and really we could repeat it for all 30 teams in the data set. We're just going to do 2 because doing it for all 30 by hand would be kind of nuts. But for the Kansas City Royals, we're going to plug in their batting average for this particular season for X, and their fitted value is 798.75 runs. And the Kansas City Royal residual is what was observed minus what we just predicted. And so their residual is a negative 68.75 runs. And so what we're going to do is look at these two residuals that we just calculated graphically, just to see what they are in relation to this scatter plot. And so we could go ahead and locate the point of the Texas Rangers. And so I'm going to go back and see that they had a batting average of 28.3 and number of runs scored was 855. And so it looks like they're this point. And so what the residual represents is just the distance from this point to the fitted regression line vertically. And so this residual is very small, so we could barely kind of see that there's any sort of distance there, but that distance is the 14.3 runs that we calculated. And so it's positive because the observed response is above the fitted regression line. For the Kansas City Royals, they had a batting average of 27.5 and a runs scored of 730. So it looks like the Kansas City Royals are this point, and so their residual is a little bit larger. But it's again just the distance from this point to the fitted regression line vertically. And so that distance is 68.75, but the residual's negative because the observation is below the regression line. Because the observation's below the fitted regression line, that means that the model is over-predicting the number of runs scored for the Kansas City Royals, whereas for the Texas Rangers, their response was above the fitted regression line, meaning that our model is actually under-predicting the number of runs that the Texas Rangers scored based on batting average in percentage. All right, so hopefully that kind of makes it a little bit more clear about what these residuals actually are. And so if we were to actually calculate the sum of squared residuals for this example, what we would have to do is we would have to repeat the calculation above to find the residuals for the 28 other teams that we didn't look at. So for the other 28 teams. Then we would square each residual and add them up. And so the idea again is that if we did that for this example, which is the least squares regression line, we would get some number after we squared all those residuals and added them up, and that number would be smaller than the sum of squared residuals that we would find for any other possible line. So if we fit a line maybe like this, we could again calculate the sum of squared residuals for this line, but it's going to be larger than what it is for this least squares regression line. Okay. So again, this is kind of, it's applied regression, but we are just kind of really briefly talking about a more theoretical aspect in this simplest possible case. But now we're kind of going to leave the theory behind for good, well, mostly for good, and move into some more interpretations and things that we could do with this simple linear regression model.